Okay, so we're going to continue on with section 5.5 and in the rigging and mechanical installations section of the book. We're going to talk about wire rope and wire rope sling. So wire rope, technically, some people call it wire cable. It's a sexually woven rope with steel instead of fiber. And this kind of goes through a good background in the different kind of wire rope out there. So these are all excellent bits of information. None of them are critical for using the rope, but they're good overall background. So read through all that. They also give you a great table on page 116, which is really useful for understanding how to use the different kind of wire ropes. By reading through this, you understand, and then you can look at this little table here to get an idea what the cross section looks like. But by reading through this, you'll understand how and where you would use the different kinds of rope. So this is an excellent table to keep on reference. And this is why one of the key reasons why I love this book. It shows you the cross section. So if you find a bit of wire rope laying around, you'll know what it is. And then it gives you the table on how to use that rope, right? But I will emphasize one other area as well, inspection. Wire rope needs to be inspected. It needs to be cleaned, inspected, and evaluated. If you find broken individual strands, then you know that wire rope has begun to be compromised. There is usually a number of strands or kinking of strands, minimum number that you're going to call unsafe. Like if you just use exactly one strand, it's usually still considered safe to use. However, I'm going to recommend if you find any strands broken or any kinked or damaged areas on that cable, that you bring that to your supervisor and have them review and approve the use. Don't just go ahead and use any cable if you see damage on it. Make sure you have approval to use that cable. And with wire rope, we also have a reduction in load based on how you're lifting. And we have all the same attachments with wire rope. Wire rope, you've got a variety of different kind of loops. So the higher the angle, the safer the loading is. As soon as you get a really, really tight angle, like this last picture here on the right in figure 538, that 30-degree angle means that you're kinking over that edge on the load, and now you have to use only, you can only assume that that load is half, right? Your loading factor is 50%. One other mention, if you ever use any kind of wire cable, they recommend 3 clips per end. I've used many times just 2, but that's not technically correct. You need 3 clips or 3 of these little attachments per end. You should always put your little eye in, and you always put the loop side or the U-bolt side on the dead end of your wire cable. I have to admit that I've installed a lot of wire cables that I didn't quite do this right until I learned to do this right. So this is a very important little description here. And there's lots of tidbits of information. This is a very useful section. And they even give you a recommendation for spacing between your clips. Great. Chain. Chain is the most common method of lifting things in most industrial sites. You're going to find chain used a lot of places, and there's a lot of very important terms to use in chain. And once again, inspection is critical. Inspect it every time you use it. Every single time. You don't know what might have occurred the last time you picked up something with that chain, and you need to clean it before you inspect it. I emphasize that. Once again, we've got OSHA 1910-184 as requirements. And you should always, if you find any damage to your chain, you should always bring that to your supervisor or to an experienced rigger before you use that chain. The book goes through a variety of attachment point kind of discussions. These are all very important terms. These are shackles. Shackles is a very, very important term. These are different kind of shackle types. And depending on where you're hanging a sling off of a shackle, it gives you different loading capability. Chain grades. A lot of times we use chains without having any idea what their grade is. They do come in different grades of steel, just like you would have for a bolt. The stronger the steel, the higher the grade is, and generally you have to assume it's the lowest grade if you don't find any documentation on that chain. Learn about the different chain grades. They all have different purposes and they all have different strengths. So the last thing I'm going to emphasize is pre-lift planning. This is a very short section in the book. We're only talking about a page, and it's very, very important. The first step in pre-lift planning is inspect the load, and that also means work with an engineer to understand all the different aspects of lifting that, attachment points, components of the load, everything there is to learn about that load. Talk to the manufacturer if you don't know. Get their information. So research it. Don't just inspect it with your eyeballs. Research it. Come up with all the information you need to lift that heavy object, especially if it's worth $500,000 or something like that. Number two, use that data to come up with how you're going to distribute the weight and pick that object up. Use the manufacturer or an engineer to come up with that, or an experienced rigger. Three, make sure you have the right personnel. You may not just need the guy to run the hoist, you may need a couple of spotters, and you may want somebody standing back to keep people away from getting into the area while you're doing the lift. So do all of your planning for personnel ahead of time and inform everybody involved and everybody who might wander into that area. Equipment and inspect. Actually, this is where you find all the equipment you need, verify they're operational at full capacity, and inspect all the slings and chains and anything else you might need. And last according to the book, is determine the path. So that's the whole thing, from point of lifting the object to point of putting down the object, and every possible risk along the way. And then that brings me to my favorite thing, is plan for the what if. What if it does tip over? What do you do then? Do you want a contingency in place in case you start to have a problem? When you start the lift, do you want to pause to make sure that the loading on the chains is appearing equal, right? Or do you just want to take it straight up? Or would you rather pause after it's one inch above the ground to see that everything is good to go?